So, ladies and gentlemen, first of all, like I mentioned with secant and cosecant, there are places on the unit circle where tangent is undefined. At what angles is tangent undefined? Do you remember back from your unit circle? Where is it undefined? It's undefined at pi over 2 and 3 pi over 2. So what happens graphically is when we go to construct the graph of tangent, what's going to happen at pi over 2 and 3 pi over 2? We're going to end up with the vertical asymptotes. Again, we're only graphing one cycle of tangent. So what's going to happen is we're going to begin and end each graph with an asymptote. The period, if you remember back when we were talking about tangent from the unit circle, because tangent is positive in quadrants 1 and 3, what happens is graphically, instead of having a period of 2 pi, tangent is going to have a period of pi. What happens, the graph begins repeating itself after pi units. So some other characteristics we need to talk about with tangent. Sine, remember, is an odd function. Cosine is an even function. Its reciprocal functions are the same. So secant, just like cosine, is even. Cosecant, just like sine, is odd. Tangent is an odd function. So tangent is odd. Again, just like secant and cosecant, it has no amplitude. Amplitudes only apply to sine and cosine because, again, there are no max or min values. So, again, there's no amplitude because tangent, just like secant and cosecant, does not have a max or min. The period is pi. So, unlike sine, cosine, secant, and cosecant, tangent is only going to becomes repetitive after pi. So when we are going to construct our graph of tangent for the parent function, because we're going to begin and end our cycles with a vertical asymptote, the parent function interval we're going to use is going from negative pi over 2 less than x less than pi over 2. So tangent is the one parent function that will not start with that first key point at 0. We're going to look at the vertical asymptote at negative pi over 2. Because what would happen if you take a look at this graph, if I did start at 0, notice my graph would be cut off and have a vertical asymptote in the middle. So what happens is that's why we're going to be looking at this graph from negative pi over 2 to pi over 2. All right? Now, you definitely need to make sure you're going to use your compound inequality. Because you're not starting at 0, if you have a period change and or a phase shift, because a period change is going to affect both the left and the right-hand starting points of this graph. You're no longer starting at 0. So the bookend method looks a lot different, which is just your inequality from sine and cosine. It's going to go from negative pi over 2. You still want to sandwich that bx minus c between your inequality signs to pi over 2. So that inequality is going to be a lot different. And like I mentioned, you begin and end the graph with a vertical asymptote. So some changes in what you're used to with a sine, cosine, secant, and cosecant. Big thing is period is pi, and again, your parent function intervals are no longer starting from 0 to 2 pi. It's going to go from negative pi over 2 to pi over 2. All right, and again, your inequality, this is a must. All right, so let's take a look at the parent function here. So here is your parent function for tangent of x. So first of all, let's take a look at this particular function. Again, I'm going to start from negative pi over 2. I'm going to end it at pi over 2. Again, if you have a period change or a phase shift, that will change the divisions along the x-axis. So now let's find the midpoint. What is the midpoint between negative pi over 2 and pi over 2? 0. And then the midpoint between negative pi over 2 and 0 is going to be negative pi over 4. And then the midpoint between 0 and pi over 2 is pi over 4. So that takes care of the divisions along the x-axis. So negative pi over 2, negative pi over 4, 0, pi over 4, and pi over 2. So now going back to the unit circle, as I just mentioned, you just told me tangent is undefined at 3 pi over 2 and pi over 2. So at pi over 2, remember the tangent is undefined. Remember, the tangent of negative pi over 2 is equivalent to the tangent of 3 pi over 2. So the tangent of negative pi over 2 is also undefined. So now going back to the unit circle, let's talk about the tangent of negative pi over 4. Well, what quadrant is the angle negative pi over 4 going to be located? 4. So again, down here, negative pi over 4. The question is, what's that tangent value? First of all, is tangent positive or negative in quadrant 4? Negative. So I know it's going to be negative. So now the big question is, what's the tangent value at all of your pi over 4 angles? 1. So I know a tangent of negative pi over 4 is 1. Tangent of 0. 0. Now we're going into quadrant 1. Tangent of pi over 4 is tangent positive or negative in quadrant 1? Positive, so it's going to be positive 1. So then I can start constructing the graph for tangent. So again, at negative pi over 2 and positive pi over 2, I have my vertical asymptotes. At negative pi over 4, I have a value of negative 1. Then I have the point 0, 0, and then at pi over 4, I have the value of 1. The tangent curve looks a lot like from algebra that x to the third graph you used to graph, the cubic functions, with the asymptotes sandwiched in between. Again, if you were to graph another cycle, you would have another cubic function. All right, so the domain. The domain of tangent is going to be all reals except odd multiples of pi over 2. Negative pi over 2, pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, etc. would give you those asymptotes. The range. The range, however, is going to be all real numbers. The period, like I mentioned, is pi. And you have vertical asymptotes at x equals pi over 2 and x equals negative pi over 2. So now, when you go back, kind of relating how we've been graphing sine and cosine and secant and cosecant, you can still use a lot of the same techniques that we were doing to construct these graphs. Notice you're still going to have a vertical stretch or compression, or that a value. Notice in the parent function that a value is 1. So after you plotted the first point after your first vertical asymptote, notice you were 1 unit below the baseline. Then it was a baseline point, and then notice you were 1 unit above the baseline. So you can still use this coefficient of tangent. If you want to remember, this point is the minimum, base, maximum. Technically, we know that there is no min or max, but again, this negative 1 is always going to be that a value below. So you start low, base, higher point. All right, so if you want to kind of relate it to what we've been doing with the sine and the cosine. All right, so any questions about the parent function for tangent before we start shifting the thing around? All right, let's take a look at this example here. So first of all, what's the period? Well, the period is pi. You're going to find the period exactly like you've done for sine and cosine, except instead of taking a 2 pi and dividing it by the b value, it's going to be pi divided by the b value. So you find the period very similar to the way you did for sine and cosine. It's just instead of 2 pi divided by b, it's pi divided by b. Vertical asymptotes we'll come back and fill in a minute. Do we have a phase shift? You identify phase shifts just like you do for sine and cosine. Is there a number added or subtracted to x inside parentheses? No, so there is no phase shift. Do you have a vertical shift? Yes, we're going to be, again, the plus 2, just like for sine and cosine, we're going to shift this up 2. And again, you have a vertical stretch that's equal to 3, which you also consider that a value going back to sine and cosine. So any questions on identifying your transformations so far? So just like for sine and cosine, that vertical translation is going to move your baseline. Identify the baseline. Where is your baseline going to be? The baseline is going to be at 2. Because you have a vertical stretch of 3, I know those other key points will be 3 units above the baseline, which will put me up here at 5, and 3 units below the baseline, which will put me down here at -1. So when you have the A value and you have the vertical translation, you're treating it just like the sine and the cosine. Now, because the period is pi, there is no phase shift. It's just like the parent function. We're going to start at -pi/2, and we're going to end it at pi/2. So I can label my x-axis. Remember, I'm starting and ending with a vertical asymptote, because that's where tangent's going to be undefined. So now there is no reflection. My A value is 3. So what that means, at -pi/4, I'm going to be 3 units below the baseline, which will put me down here at -pi/4, -1. Next is a baseline point. So 0, 2 will be the next point. And then finally at pi/4, I'll be 3 units above the baseline, which will put me up here at 5. So there is your tangent graph with the vertical stretch of 3 as well as a vertical shift going up 2. So any questions on how you can graph a tangent with that vertical stretch and the vertical shift? So my vertical asymptotes are at x equals -pi/2 and x equals pi/2. Remember, you always give me equations of vertical lines when I ask you for asymptotes. Okay. So any questions on that particular example? Okay. Let's take a look at another one. So just like for sine and cosine, what's the negative sign in the front going to do? The negative sign is going to give you a what? What's the negative sign going to do? That's going to be a reflection. I have a vertical stretch again, up 2, which is also your A. Now remember, the B value, just like sine and cosine, is the coefficient of x. So what does that tell me about the period? I'm going to have a period change. So to find the period, remember, it's still going to be divided by b, but instead of being 2 pi, it's going to be pi divided by your b value. So then what's my period going to be for this particular graph? It's going to be pi over what? 4. Do I have a phase shift? Is there a number added or subtracted to x here? No. Do I have a vertical translation? Am I shifting this graph up or down? No. There's no number added or subtracted to the function. So now this is where, ladies and gentlemen, because you have the period change, and remember, tangent's not starting at 0. You want to set up that inequality so you know exactly where to start and where to end this particular graph. So remember, for tangent, the inequality or bookend goes -pi/2 less than. Your bx is going to be 4x less than pi/2. And you want to solve for x. So how would I solve for x here? I would do what? Divide by 4, which means I'm actually going to multiply by what? 1 over 4. So when I solve this, I end up with -pi/8 less than x less than pi/8. So that tells me that I'm going to start this cycle at -pi/8, end it at pi/8. So any questions on where I got the starting and ending values from? So now you still have to find the other 3 divisions on the x-axis. What's your midpoint between -pi/8 and pi/8? 0. The midpoint between -pi/8 and -0 is going to be -pi/16. And then the midpoint between 0 and pi/8 is going to be pi/16. So any questions about the divisions along the x-axis? Where's your baseline going to be? Your baseline is going to be where? 0. So now my vertical stretch is 2. So that means the higher point is going to be 2 units above the baseline. The lower point will be 2 units below the baseline. So I can label my x-axis negative pi over 8, negative pi over 16, 0, pi over 16, pi over 8. No matter what with these cycles, ladies and gentlemen, with tangent, what are we always going to start and end with? We're always going to start and end with our asymptotes. So I know at negative pi over 8 and pi over 8, I'm going to have a vertical asymptote. Now remember, with the parent function, the pattern of the points went min, base, max. That's the pattern of the point for the parent function. But what other transformation do we have here? We have to consider what when we graph this? We have to consider the what? Reflection. So just like for sine and cosine, if you have a reflection, what's going to happen when there's min and max values? They're going to do what? Reflect. So this is going to be a max. This will go to a min. So at negative pi over 16, the key point is going to be 2 units above the x-axis. Then you have a baseline point, and then at pi over 16, that max will be 2 units below your baseline. So that's what your tangent curve looks like with a reflection. So any questions on example 2? So you guys go ahead and try example 3 for me. What's your period here? What's the period going to be for number 3? Pi. Do you have a phase shift? Do you have a phase shift here?
I don't believe it.
And what is the plus 5 doing? That plus 5 is going to make your graph do what? Up 5. So you guys go ahead and try that for me.